Ladies and gentlemen, welcome back to 5 Minutes of Math. This is Mr. Lunsford, and I am glad you joined me this evening. Tonight's homework is for the evening of February 27th, 2018. We're looking at part 2 of that homework assignment. And I call this one the Walkway Around the Pond. Let's get started. Problem number 20 asks us to look at a pond surrounded by a walkway. And the question is asking us, what is the area of the border? And here, this problem, as you can see, there's 12 feet that go from edge to edge, and it's a square surrounded by 2 semicircles. That's really going to come into play as we're solving this problem. So as you can see here, there's a 12 by 12 foot square sitting there in the center, and there's semicircles on the side. So what are we going to do with this? We're going to take it apart. So again, the pond and walkway all look like a heart that's been tipped onto its side, but when we take it apart, we're going to treat it as a square and a full circle. All right, so again, we're going from this heart-shaped thing, we're taking it apart into a box and a circle. Those 2 half circles make a full circle. Now, the box has one side of 12 feet. The circle has a diameter of 12 feet. So let's calculate the outer area first. This is going to be a case where we subtract the inner area, the part in white, from the outer area, the entire shapes. So here we have it. Our square has a formula for finding the area that says side squared. Okay, so we know the side is 12. And as you can see, 12 is right there in red. Now the circle has a diameter of 12. So the radius is going to be half of the diameter. Now you could do diameter divided by 2, 1/2 times the diameter, or the diameter times 0.5. Either way, it all works out to 6. So the radius is 6. And pi, except for one case that I know of so far in our homework, we're going to treat pi as 3.14. It really goes on forever, but that's all right too. 3.14 is what we're going to use for pi in this particular problem. Now, the part that I've highlighted right here, never forget that if you get a diameter, you have to divide it by 2 in order to get your radius so you can figure out the area. We don't use diameter for area, we use radius. All right, so we start with 12, and half of 12 is 6. So that's critical. You may see this somewhere on an SOL. All right, so side squared, here we have the area is 12 squared, and the area is 144 feet squared. All right, now we move on to the circle. The formula is pi times radius squared. So the area is 3.14 times 6 squared, 3.14 times 36 gives us an area of 113.04. All right, and we add those up, and we get a total area for that whole shape of 257.04 feet squared. That's the outer area of the shape. Now let's look at the inner area. So look again at the shapes, and notice how we're highlighting the inner area. So we're going to find the inner areas of both of those shapes and subtract that from the outer. So let's look at the square first. We know we have a 2-foot walkway on at least 2 sides, on the left side and the top side of that square. The insides aren't touched. So we don't use 12 feet. We're going to use 12 minus 2. We have a square with a side of 10 feet. All right. Now we go on to the circle. The circle has 2 feet taken from both sides. Okay, there's 2 feet taken from both sides. So it's not going to just be 12 minus 2. It's going to be 12 minus 2 minus 2 equals 8 feet. All right, so this circle is going to have a diameter of 8 feet. Now what does that mean? The square, we've already said the side is 10. The circle, though, when that diameter is 8 feet, that means the radius is 4 feet. Okay, and if we move on here, we see that we square 10 and we end up with 100 feet squared. That's the inner area of that square. Then we move on to our circle. The area is 3.14 times 4 squared, 3.14 times 16, and then 50.24. Add those 2 areas up, we get 154.24 feet squared. Now what do? Well, here's our walkway again. We're going to subtract the outer area minus the inner area. And we should get the area of the walkway, right? So the outer area is 257.04. The inner area is 150.24, and we get 106.8, but that's not the right answer. Okay, and that might throw you a little bit, but don't let it. That's not right, because there's something that we skipped. Let's take a closer look at this shape. This in pictures is what we subtracted. We subtracted that entire black area on the left hand side from the orange area on the right hand side and got 106.8 feet squared. That should represent that black outline around the orange area. Okay, but I want y'all to take a closer look at this. Here's our original square that we removed when we determined the area of the orange section. There's a square, there's a circle, but here's the actual shape. Okay, compare those two. What we subtracted at the top is not what the actual shape looks like. We skipped something. What did we skip? We skipped that tiny little square right there. And I had to really take a good look at that and do some thinking to figure out how to best to explain that to you. But this is the part that we missed. See that little square? The square is part of the walkway. So if we're taking a closer look at it, that square has a side of 2 feet. And since it's part of the walkway, we have to add that area to what we got earlier to get the actual real area of our walkway. So let's do that. We have a square with a side of 2. Of course, 2 squared is 4. 106.8 plus 4 is 110.8. That's the area of that walkway surrounding that pond. Okay, that's all there is to it. Y'all take care, and remember, math is not just about numbers, it's about the relationships that surround us every day. Y'all have a good one.